Day 53 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Day 53. I don't know about you guys, but I don't feel tired at all. I don't feel burnt out at all. I'm just getting started. We're only on day 53. We have a long way to go, guys, but I hope you guys have been learning something so far. I know I have. And the knowledge has been compounding every day. Learn something new, and we just adding on to what we learned yesterday. And today we're still in the LeetCode 75. We're still in the DFS part of the binary tree, so we've been learning that, and I'm glad we've done a few of these problems in a row. That's why the LeetCode 75 is so important, guys, because it's easy to just jump around in different type of questions when you're not following any type of structure or any type of path. The LeetCode 75 gives you groups of questions that are similar to each other. So after you learn one, you can learn the next without forgetting what you learned last time, because they're all similar. So right now we're doing all the DFS binary trees. I think this is the last of the DFS binary tree part of the LeetCode 75, guys. But hey, I hope you're learning, guys. I'm learning. I'm starting to see a difference in my understanding and of how the code works, and I hope you guys are too. Now, with that being said, guys, don't forget, bring your mouse, bring it right over here and click that subscribe button for me, guys. And then after you do that, go ahead and smash the like button for me. And then after you smash the like button, I need all of my bankers. I repeat, I need all of my bankers in the comment section, dropping the bank emoji, so we could grow this community, we could help this Swift community grow, and we could help people learn Swift and get more people involved in Swift, so we could get Swift popping out here. So with all that being said, let's look at the question we have here today. Today we have question number 236, lowest common ancestor of a binary tree. The difficulty level is medium, but you guys know we're not going to let that deter us. We're still going to keep the solution as simple and easy to understand as possible, guys, because we're all learning and we're all trying to understand how Swift works and how these data structures and algorithms work. So in order to do that, I'm trying to keep the solutions easy so we understand. So at the end of this video, I'm hoping you guys understand how the code works and how it runs and why we got the answers that we got. So let's read the question and see what it says. It says, given a binary tree, find the lowest common ancestor, LCA, of two given nodes in a tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. So let's look at these examples to see what they're talking about. So we have input root, then we have the list of nodes, and we look P equals 5 and Q equals 1, and the output is 3. The output is 3. The explanation says the LCA of node 5 and 1 is 3. So let's break that down. We have P equals 5, which is right here. We have Q equals 1, which is right here. The output is 3, which is right here. Why is it 3? It is 3 because that is the lowest common descendant. These are the lowest common descendants of 3. If you look, so first we look at 5, then we look at 1, and we wonder, what do 5 and 1 have in common? It's 3. They both started at 3. This is where the split starts, so that is why we're returning 3, because this is where the split starts, and they both, 3 is a common, these are common descendants. These are 5 and 1 are both common descendants of 3. 3 is both of their ancestors, which is why we returning 3. So let's look at example 2, just so we can really bring this home and you guys can understand what's going on. So we have the input root, we have the list of values, we have P equals 5 and Q equals 4. The output is 5. The explanation, the LCA of nodes 5 and 4 is 5, since a node can be a descendant of itself according to the LCA definition. So let's see. First we have P, so let's locate P. We locate P, is right here, is 5. Then we have Q equals 4. Let's locate 4, and 4 is right here. Now if you look, 4 is a descendant of 5. That's obvious because it goes, you could follow the path, it goes 5, 2, 4. So obviously 4 is a descendant of 5. However, you might look at 5 and be like, where does how do we find the descendant of 5? And like it says up here, remember, a node can be a descendant of itself. So in this case, 5 would be a descendant of itself, and 5 would be the lowest common ancestor because there's no other ancestors after it. It's just 5. It goes. So that's why 5 will be the lowest, because the root is 5 in this scenario. So let's look at example 3. Root is 1 and 2. P equals 1. Q equals 2. The output is 1 because, remember, guys, how the trees work. It goes from left to right. So 1 would be first before 2, which is why 1 would be the output, because it would go 1 then 2, and 1 would be a descendant of itself, and 2 would be an ancestor of 1. So I hope that makes sense to you guys. Just see where the split starts and how find their common ancestor, where they all can start from. In this case, it would be 3. I know these examples are a little easy, but I hope they make sense. That means they should make sense. 5 and 1, 3 is the common ancestor. That's obvious. Then we come down here, 5 and 4. 5 is the common ancestor because, as it says, according to the LCA definition, a node can be a descendant of itself, and in this case, 5 is a descendant of itself, and 4 is the Q, so it would be 5, since P is 5. So let's see how we're going to solve this question, guys. As you know, the solution, we're keeping it simple. I'm going to break it down as we go so you guys can understand a little better. So first we're going to say if root is equal to nil, then we are going to return nil, because that means there is no root, and if there's no root, then there's no common ancestor. Then we're going to come down here, we're going to say if root, and this time we're going to put 3 equal signs P, or we say root, we put 3 equal signs again is Q, then we're going to return we're going to return root. And what this right here, guys, is going to do is it's going to check if root and P point to the same instance, or it's going to check to see if root and Q point to the same instance. And this is going to check basically if this is helping with this right here, where we allow a node to be a descendant of itself. So this right here is going to check to see if the root and P are descendants of themselves, or if they need to be. Then we're going to put return root, no E at the end. So then that's how we're going to handle that, to see if it's a descendant of itself or not. These 3 signs, these 3 equal signs, is just checking to see if root and P point to the same instance or not. And same over here, if root and Q point to the same instance or not. If they do point to the same instance, then we're going to return the root, because that would be the descendant of itself. Then we're going to come down here and we're going to say let left equal, then we're going to use some recursion here. We're going to say lowest common ancestor. Then we're going to say root, dot left, comma P, comma Q. And who can guess what we're going to do next? You guess it. You already know we got to do the right side next. So we're going to say let right equal. Then we're going to do some recursion. We're going to say lowest common ancestor. Then we're going to say root dot right, comma P, comma Q. Then we're going to come down here and we're going to check, and we're going to say if left does not equal nil, and right does not equal nil, then we are going to return the root, which is going to see if we're gonna find if they both have values, then we're gonna find the root or the ancestor of those two values. So, which would be the root in this example. The ancestor would be the root in this case. Then we're gonna say return left does not equal nil. Then we're gonna put a question mark. Excuse me. Yeah. Then we're gonna put the question mark, and we're gonna say left, comma, colon right. So what this is going to do is going to check to see if left equals nil. It's going to, if left does equal nil, and that this is going to check to see if left does not equal nil. If left does not equal nil, meaning left has a value, then we're going to return left. However, if left does equal nil and there's no value for left, then we're going to return right. Remember, guys, this is a Boolean, so it's basically checking to see if it's true or not. If it is true, we're going to return left. If it's not true, then we're going to return right, guys. So I hope that makes sense to you guys. Let's run it and see how it runs. See what happens. And it's accepted, guys. So let's submit it. Let's submit it. See what that time is looking like. 27 milliseconds beats 80.58% of users with Swift. It's not bad at all, guys. I hope you guys understand the solution, and I hope you guys understand the question. I know a lot of these LeetCode problems, understanding the question might be the hardest part sometimes. So I hope that made sense to you guys. One more time, we just checking for the least common ancestor, basically. So this case for this example is 3, and for this example it is 5 because a node can be its ancestor or a descendant of itself. Excuse me. So until next time, guys, I'll see you guys later.